Hello everyone, this is Mr. Ray. Welcome back to our next lesson in grade 10 applied math. We're working in the unit of linear equations. The last two lessons, I know they were pretty intense, or they could be intense, but basically we learned techniques how to take any linear equation and solve it. And what that meant was find the value of the variable that makes the equation true. So I gave you a 6-step process in the last lesson, lesson 2, and hopefully you're able to practice that and become very confident in solving equations. So what we're going to do today is go a little bit beyond just looking at equations. The whole purpose for equations of any type is to actually use them in real life, and we don't just give each other equations to practice. That's not that gives us skills, but it doesn't really give us a reason for using them. So today, hopefully, I'll show you, give you examples of some fairly, from basic to medium level linear equation word problems without any equations given to you. And what we're going to learn is how do we convert those 1 or 2 or 3 sentences into an equation that we can then solve using the techniques from the last 2 lessons. So we're going to be going through that today. So I've got this table here. This is kind of like you might have an English to French translation guide. This is my English to math translation guide. So on the right here, we've got our words in English or phrases in English and what the equivalent math operation or expression or term is. So we're going to use this when we're reading our word problems to translate that information into a math equation. So for example, the words is, or equals, or results in, or is the same as, that is the same as a math equal sign. And we know there's always an equal sign in a math equation. So you're going to be, for sure, you're going to be finding one of these phrases inside the word problem. Okay. Once we find it, we can, cross the words off or circle them and put an equal sign. Then once we're done the whole translation process, we can go back and make our equation. Okay. The next group of terms or phrases here, combines with, added to, sum of, more than. These are all related to adding in math. So we have our plus symbol that replaces these phrases. The opposite of adding is subtracting. So we have phrases like difference of, subtracted from, or less than. That's when we would bring in our subtraction symbol. For the multiplication symbol, we've got things like multiplied by. Obviously, that's pretty close to a multiply symbol. Product of is quite common. Times, that's the word we used to use for multiply, but it still applies here. The word of, if you see it by itself, a lot of times that just means multiply. And also we have these very specific multiplications, double and triple, that could be replaced with multiply by 2 for double, multiply by 3 for triple. Okay, and then the last operation you normally see, like a division symbol, or what we're probably going to use more often would be like a division bar, like something divided by something. Okay, so there's not too many phrases for that. Divided by is probably something you'll see most of the time. Quotient of, you may see that, but that's quotient always means divide by. Okay, and then the most important one, you're going to see something in the word problem that you're going to be asked, well, what is the value of that? What is that number? What is that age? How many dollars does the person have? Something that's unknown. So when you see that, you're going to replace that because it's unknown. You're going to replace that with a variable because we don't have a number for it yet. We will once we solve the equation, but for now we're going to call that unknown thing x. Okay, so that's what this first key concept is. We're going to use this table when we're going through our word question and be able to convert it into a mathematical equation. Okay, now there's some cases, and you'll see I think a couple of examples where, well, I think there's one today and a couple in the homework where there might be more than one thing unknown. Okay, now the thing is, in these linear math equations, we're only going to use one variable, and you can call it x or you can call it any letter you want, but we're not going to introduce more than one variable. For example, if there's two things that are unknown, we're not going to call them x and y. What we will do is call one of them x, and then the other unknowns, there could be one or two other unknowns, there will be some relationship between all the unknowns. There has to be, okay, in these types of questions. For example, if I was talking about 3 consecutive numbers, okay, we don't need a separate variable for all 3. We can call the first number x, and then with consecutive numbers, consecutive means in a row, the next number after x would be x plus 1, and the next number after that would be x plus 2. So instead of having 3 different variables, we have 3 different expressions for the 3 unknowns. So we'll end up actually solving the equation for x, and once you've got the value of x, you just go back and go, okay, well, that was the first number, that means the second number would be x plus whatever x was added to 1, and the next one would be, you'd add another one. Okay, so you'll never be having more than one variable, and you're totally welcome to use x all the time. Or if you want to feel a little bit more adventurous, you could give it a letter that that has something more to do with the problem. So say you're calculating the number of fish. Maybe you want to give that the variable the letter f instead of x. It's again totally subjective. Whatever you like to do. If you want to be safe, call the variable x every time. That's good. Or if you want to be more adventurous, that's good too. Okay. So we're going to jump right into some. We got 4 examples for today, followed by some homework questions with some similar style questions. So for each of these following word problems, we're going to translate the word problem into an equation. Okay. Now you could read these questions and then try to guess what the number is. Well, that's not the purpose of math, really. We want to come up with a way of doing it quickly, and so you could apply this skill to some even more complicated questions where there's probably no hope of doing it in your head. So you need to get these skills. I'm giving you some fairly straightforward questions so that you can develop those skills. Okay, once we've got the equation written, we're just going to use what we used in lesson 1 and 2. We're going to solve the equation, get the value of the variable, and then people always forget to do the last part here. You have to answer the word question with a word answer. Okay, so we'll talk about that when we get there. Okay, first question here, example 1. Very, very short, but again, you don't see an equation here like you did in the last 2 lessons. I'll read it through and then we'll go through the translation process. A number added to 7 is 13. What is the number? Okay, so you can kind of go left to right through the sentence, or you could, when you see something you recognize, you could do it, back and forth. It doesn't have to be sequential, but once you're done, that's when you're going to apply all the information to create your single equation. So as I read this, I go, okay, if you remember, a variable was something unknown, any unknown number. So right away, I can see that phrase, a number. Okay, that's the thing we don't know. So I'm going to put a circle around it and just put an X, like the letter X, not the multiply symbol. So that I could say X is added to 7. Okay, so I'm going to keep going. Added to, well, this is pretty obvious. That's the addition, plus sign. And then the 7 here, I don't really have to change that. That's a number. That won't change. And then the word is, if you remember, is in our translation guide. That was the first case of a word for equals. So that's equals. Okay, and then 13 again is also a number. It's not a variable. It's 13. So what I'm going to do here is now try to create an equation from this translated version of this word question. So it says a number added to 7. So this is basically if I added x and 7 together, well, that would be just x plus 7. And then is an equal sign and 13. So I've got my equation here, which came directly from that sentence. Okay, and we're asked to find what the number is. Well, in this case, x is the number we're looking for, so we would need to find x. If you go back to your lesson 1 or lesson 2 for this, you'll see that what we have to do is subtract 7 from both sides because we're trying to get x by itself. So we do the opposite of adding 7, which is subtract 7. So x plus 7 minus 7, and we have to do it to both sides. So equals 13 minus 7, and you can see I've subtracted 7 from both sides. Okay, and now when I simplify this, the plus and minus 7s cancel each other out. I get x equals, and then 13 minus 7 is 6. Okay, so I've solved this equation. Now, we're pretty much done, but not completely done. We didn't really answer the question, what is the number? So remember, x is the number. So we want to, if somebody asks us a question with words, we give them a word answer. So the answer would be here, therefore the number is 6. Okay, and I know it's not a huge thing, like why bother? But just imagine, I always use a comparison. If your grandmother asked you this thing here, and you came back and said x equals 6, she'd be a little confused, saying, well, where's this x thing from? Okay, so it's kind of like anytime you do a word question, it's like a sandwich. Okay, so the middle part of the sandwich is your solving. Okay, and then the word question and answer, that's kind of like the bread. Okay, so you change the question into an equation, and you get your answer, and then change your answer back to a word answer. So it's always complete. So if someone says, what is the number? And you answer the number is 6, well, nobody's raising their eyebrows at that. Okay, now how can you check that your answer is correct? Well, there's a couple of ways. The way that we've learned is to substitute this back into the original equation. So wherever I see an x, I change it to 6. So 6 plus 7 is 13. So that appears to work. But the problem is we kind of created that equation. And what if we made a mistake? So maybe we solved the equation correctly, but we didn't create the equation correctly. So maybe we messed up going from here to here. So if you go back, read the word information, and then plug in your answer where you need to, and see if it makes sense. See if all the information given, the criteria given, matches your answer. For example, a number added to 7 is 13. So our number is 6. So 6 added to 7 is 13. That's true. So you can kind of go back and almost leave out your equation completely and just plug it back into the words that were given to see if it worked. Okay, so that's our first example. Hopefully that makes sense. Basically, the part that we're learning is taking this sentence here and creating this equation and then answering back with words. Okay, all right. So the next question, the sum of a number and 4 is divided by 2 and the result is 5. What is the number? Okay, so as we go pulling out our translation guide here, all right, the word sum, that means plus, so the sum of, okay, that's going to be our plus sign, and a number, well, again, we don't know what the number is, it's not given to us, and it also, you can see later on, it asks us what the number is, so that's going to be our variable. And then we have our number 4, we don't need to translate, and then divided by, well, that's our division sign. Okay, I'm going to use, I'll put divided by, or I think in the definition I put A over B, just to show you it's something over something. And in this case, divided by 2, so I could pretty much put the 2 right there. Divided by 2 means something over 2. And then it says, and the result is, well, that's our equals, and then 5 is our number. So you could kind of, when you create the equation here, this one's not quite as straightforward. I just can't go left to right and create that because I'm starting off with a plus sign here. So if I was to literally write everything in the order it was written, it'd be plus x 4 divided by something over 2 equals 5. So that's not quite right on the left. You have to kind of use your logic a bit. So the sum of a number and 4. So the sum means we're adding together these two things. So the number and 4 we're adding together. Okay, so that takes care of all of this. The sum of a number and 4, that's x plus 4. If we took that and we divided it by 2, so there's our division line. Divide by 2, so we've taken care of this part. Okay, we've taken care of the 2 already, and the result is 5. So we can almost read this through now. The sum of a number and 4, which is that part there, is divided by 2, that part there, and the result is equal to 5. So that looks pretty good. It was a little more complicated than the first one. So when I look at this, and we're deciding what to do, if I'm looking at my 6-step guide from lesson 2, I'm looking at first step, do I have any fractions I need to get rid of? And I do. Okay, I've only got one fraction, so that means I just multiply everything by the denominator. So I'm multiplying everything by 2. Okay, so when I multiply by an integer, which I always do, I'm going to be multiplying the top if it's a fraction. So I have to be careful, put brackets around what was already there. So 2 times x plus 4 divided by 2 is equal to 5 times 2. Don't forget, I have to multiply both sides by 2 to keep the equation balanced. And now you can see the 2 and the 2 on the bottom. That 2 divided by 2 is 1. They cancel each other out, so you're just left with x plus 4. And then 5 times 2 is 10. Okay, so we've got rid of the fractions, and now the only thing left to do is get rid of the plus 4, which means we have to do the opposite to both sides, which is subtract 4. So x plus 4 minus 4 equals 10 minus 4. These two cancel out, and we get x equals 6. So there's our answer to our math equation, our linear equation. So let's answer the question. We'll go back and check in a second. So sometimes you forget what the whole point of this was. Just go back and read the final line. It's a question. What is the number? Well, therefore, the number is 6, which happens to be the same answer as our previous question, but that definitely does not mean all these answers are going to be 6. It's just a fluke. Okay, so if I go back, if I want to see if this makes sense, the sum of a number and 4. Well, the sum of a number and 4 would be 6 plus 4, that's 10. If I divided that by 2, that's 5. And it says the result is 5, which is what we just got. So I'm pretty confident just by looking at the words that this answer meets the criteria. I can also just plug in the equation, I get the same thing. Okay, so there's our second example. Hopefully this is making a bit of sense. Okay, so the third and the fourth, I'm going to ramp up the difficulty a little bit. So hopefully you'll see it's not as bad as it might seem. So we'll do the same thing. Well, let's read the question first. The sum of Jacob's age and 30 is the same as triple Jacob's age. What is Jacob's age? Okay, so you can see I've actually got Jacob's age other than the final question. It talks about Jacob's age twice, once here and then once over here, and I'm doing different things to Jacob's age. Okay, so I'm going to be a little more clear here. At the very beginning, I'm just going to make this statement called a let statement. Let x equal Jacob's age. Okay, so wherever I see Jacob's age, I'll know that that means x. Okay, so I can read this here, the sum. So I don't have as much room now that I've written something here. Sum, that means plus. Jacob's age, well, we know that's x. We just declared that here. And 30. Okay, so that's 30. We don't translate that. Is the same as, so that's equals. And then we say triple Jacob's age. So we saw something about triple and double on the translation guide. So double means you multiply whatever we have by 2. Triple means we multiply whatever we have by 3. So if it says triple Jacob's age, that means 3 times Jacob's age. So I'm going to put 3 times, and then Jacob's age was x. Okay, now I don't want you to confuse the two x's here. This is the variable x, and this is the multiplication symbol. So what we're doing here is we're multiplying x with 3, so that would be 3x. Okay, so now when it comes time to make the equation, so let's read through here. We've got the sum of Jacob's age and 30, so we're adding these two things together, so x plus 30 is the same as, that's where our equal sign is, triple Jacob's age. We've already talked about that, that's 3x. Okay, so you can see I've got x's on both sides, and we saw this in lesson 2, and the way we get around that, because it's kind of hard to isolate x if there's 2 of them. So what we do is we only want to see x's on the left side, so we subtract any variable terms on the right side. We actually subtract them from both sides. So we're going to subtract 3x from both sides of the equation. So we get x plus 30 minus 3x is equal to 3x minus 3x. Okay, and when we simplify that, well, we simplify on both sides because now we've got x's here that we have to combine. So x minus 3x, it's like 1x minus 3x. So that's negative 2x plus 30, which is already there. And 3x minus 3x is nothing. So I put a 0 on this side. Okay, and now the next thing we do, we've got the x term on the left side, but we have also a variable term, a constant term on the left side. We don't want that, so we're going to subtract 30 from both sides. So we have negative 2x plus 30 minus 30 equals 0, and don't forget minus 30, which we're doing on both sides. So on the left side, these two terms cancel out. So we have negative 2x equals negative 30. And then the last step, this would be, well, in the 6-step process, this is always the last step. We divide by whatever the variable is multiplying by. If you've done all the other steps, of course. So here we're dividing by negative 2. So divide both terms on both sides by negative 2. Okay, and we get equals cancel. We get x equals negative divided by negative turns to positive. 30 divided by 2 is 15. So we believe, and this is why it's nice to have this little let statement up here. You get down to the bottom, you go, what was x again? Oh yeah, x was Jacob's age. So we think Jacob's age is 15. So if we were to answer the question now, what is Jacob's age? Well, that's represented by x, therefore Jacob is 15 years old. Okay, now let's see if that makes sense by just looking at the words. The sum of Jacob's age and 30. So we think Jacob's age is 30. Sorry, we think Jacob's age is 15. 15 plus 30 is 45. Okay, is the same as, so kind of the left side here, this is 45, is the same as triple Jacob's age. So Jacob's age was 15. Triple that is 45. So we basically got 45 is the same as 45. So that seems to be the correct answer. Just let me make this a little more readable. Okay, and like I said, you can still check your equation, your original equation, plugging in x equals 15, see if it works. But there is a slight problem when you've created this. There is a chance that maybe you messed up when you created this equation. So checking against the original equation is not quite the same as checking against the word information. So hopefully you can see that. Because maybe you said x minus 30 equals 3x, which would be wrong. All right, last question here. This is the tougher. Okay, let's read it first and then start going through it. Nana has a sister who is 2 years younger than her and a brother who is 3 years older than her. The sum of their ages is 49. How old are Nana and her siblings? Okay, so if you remember from the key concepts, okay, we can't have more than one variable. And in this question, we're being asked to find the ages of 3 people, Nana, Nana's sister, and Nana's brother. So we can't just use X, Y, and Z as variables. We can only use one. So now, there's usually one value that's probably the most important one that relates to the other unknowns. So in this case, we could definitely say that's Nana's age. So Nana's age, if we knew Nana's age, we could probably figure out how old her sister is, because her sister is 2 years younger, and we could figure out what her brother's age, because her brother is 3 years older. So what we're going to do, before we do the translation, since we already know that we've got to find these 3 things, let's figure out what we're going to call them before we start making the equation. So, like I said before, Nana's age is kind of the central unknown, because we can use it to get the other 2. So let x equal Nana's age. Okay, and so the next person, let's look at her sister. Her sister is 2 years younger. So if Nana was x, how old would her sister be? Her sister would be 2 less than x, because x is Nana's age. So if I come up with an expression for her sister, x minus 2 would be Nana's sister's age. Hopefully you can see that. So we'll call it sister's age. X minus 2 equals sister's age. And her brother is 3 years older. So if Nana's x, that would make her brother x plus 3 years old. So we have x plus 3 equals brother's age. Okay, so we've got 3 unknowns, but we've only got one variable. And that one variable is used for all 3 unknowns, but they're not all the same because they're different ages. X for Nana, x minus 2 for the sister, x plus 3 for the brother. Okay, so now that we've kind of sorted that out, and I think it's important to do that right from the beginning, we can kind of go through here. and figure this out. So Nana has a sister who's 2 years younger. We've kind of got that here. So we could, if we wanted to, we could say, well, that's her sister is x minus 2. Okay. And her brother's 3 years older, so that's x plus 3. The sum of their ages. So this is the sum of not just her brother and her sister, but Nana, her brother, and her sister is, and there's our equal sign. Remember, we always have an equal sign. So what this is saying is the sum, we're adding these up. We're adding up Nana's age, her sister's age, and her brother's age, and that equals 49. So when I make the equation here, it's going to be Nana's age plus, and I'll put it in brackets here just so you can see it better, her sister's age. So don't forget, when you have sum, the plus, it could be you're adding more than 2 things. It could be 2, 3, 4, or even more than 4 things. So x plus x minus 2, that's her sister, plus her brother's age is x plus 3. So if we add those 3 ages together, the result is equals 49. Okay. So now we've translated the words into an equation. We've kind of got our documentation here. What are each of their ages in terms of x? And so now what we want to do is solve it for x. Solve this equation for x. So once we're done, that will give us Nana's age, because that's what x represents. And then once we've got Nana's age, then we can figure out by subtracting 2 to get her sister's age, or adding 3 to get her brother's age. Okay, so these brackets here aren't really required. I just put them in there so you could see the ages kind of separated. So I can just write them without the brackets. If I had something multiplying in front, I couldn't just take away the brackets. I have to distribute, multiply through them. Okay, so I've taken off the brackets, and now you can see if we're doing this in our 6-step process. I think the first step is fractions. There's no fractions. Second step is brackets, no brackets. Third step is simplify. So simplify means that are there terms that I can combine on the left side? And definitely there are. I've got 3 x terms, and I've also got 2 constant terms. And here's something you can do if you want to. You can rearrange the order of these. If I wanted to, I could put all the x's first, x plus x plus x, and then the minus 2 plus 3 at the end. It doesn't really change anything, but allows you to at least focus in and say, well, I'm adding these together and I'm adding these together separately, which is a good way to start off doing this. So x plus x plus x, well, that's 3 x's. So 3 times x. And then negative 2 plus 3 turns into plus 1. And that equals 49. Okay, so you can see it looking more and more like equations from lesson 1 and 2. So what we do next is we subtract 1 from both sides. Okay, and the plus 1 minus 1 cancel. So I get 3x equals 49 minus 1 is 48. And then this will be step 6, the division step. We divide everything by 3. So 3x over 3 is equal to 48 over 3. 3's cancel. I get x equals 16. Okay, so that's pretty good. That tells us, what does that tell us? Well, what's x? X is Nana's age. That tells us that Nana is 16 years old. But it also tells us the other siblings. It tells us, if I plug in x here for her sister, 16 minus 2, so her sister is 14, and her brother is 16 plus 3, 19 years old. Okay, and that's what I need to put into the word answer. Therefore, Nana is 16, her sister is 14, and her brother is 19. Okay, and I got the last two from just going back up here. That's the power of, if you have different unknowns that rely on one of the other unknowns, is to write down what each of them is in terms of an expression and the variables. Okay, so how do we check this? Well, we could plug it in here, but you'll see that definitely works. But let's go back to the words. Okay, so let's just check the information here. Nana has a sister who's 2 years younger. So is that true? Yes. Her sister's 14, Nana's 16. Her brother's 3 years older than Nana. So that would be 16 plus 3, 19. That's true. And the final thing, the sum of their ages is 49. So if I add these three ages up, I get 16 plus 14 is 30. 30 plus 19 is 49. And that is definitely true. It meets the information in the question. So when you check that way, much more confident that you're right, because you can actually see if your answer satisfies the information given. Okay, so that's it for the lesson. There's some questions to work on that practice this skill of translating into equations. So that'll be it for this unit. So please make sure that you know how to do the solving of equations, because you can see for this lesson it was required as well to be able to take an equation and solve it. Okay, so that's a skill that I'm assuming that you've got from the previous lessons. Today's skill was creating the equation from the word information and then providing a word answer. Okay, so that's all for today. We'll see you again at the next math lesson.